In this video, I'm going to talk about absolute value inequalities. The learning target for this video is students will be able to solve and graph absolute value inequalities. So we're going to talk about inequalities instead of equations. So we're going down here. The steps for solving absolute value inequalities are very similar to the steps for solving absolute value equations. The first step is to isolate the absolute value. Isolate the absolute value. The second step is to write not two equations, but to write two inequalities. So to write two inequalities instead of equations. And the third step is to solve and graph. Third step is to solve and graph. Okay. And also to make sure that your answer makes sense. Because there are going to be examples with no solution. Your answer makes sense. Your no solution or infinite solutions are the ones you're going to be looking at. And we'll talk about those in a second. But so the steps are basically exactly the same, just you're writing two inequalities. Okay. For the second step, it gets a little more complicated than just writing the thing inside is equal to the positive version and the thing inside is equal to the negative version. There are different cases. So if you have that the absolute value of x is greater than a, it is different than if the absolute value of x is less than a. If you've isolated the absolute value down to the absolute value of x is greater than a just being some random number, you are going to write two inequalities with or in between. And you can remember that by thinking great or. Great or. You can remember that by thinking great or. So what it means is I'm going to write that x is greater than a or x is less than a. Oh, not less than a, less than negative a. So I'm just going to write exactly what I see here without the absolute value bars. That's going to be my first inequality. And then my second inequality is going to be, I'm going to flip the sign. So if it was greater than, I'm going to make it less than. And I'm going to flip this number on the right-hand side to its opposite. So if it was positive, you make it negative. If it was originally negative, you make it positive. And this is the two inequalities that you're going to write. We'll talk about that a little bit more in a second of why it's like that, but I'm going to just go into if you have the absolute value of x is less than a after you've isolated the absolute value, then it means that you have two inequalities with and in between. And you can remember that by thinking less than. Than. And that will help you, remember what word goes in between. And it is important which word is in between because it will completely change the answer. And so if you see this, it means that x is less than a. So you just rewrite exactly what you see here without the absolute value bars. That's your first inequality. And then your second inequality is instead of less than, x is greater than the opposite of a, which is negative a. And the word in between is and. So this is going to be your answer. If you have great or, you have or in between. If you have less than, you have and in between. This example here can also be, or these two inequalities can also be morphed into one, or it's still two inequalities, but they can be morphed together since this means that x is in between two numbers. X has to be greater than negative a, and it also has to be less than positive a. So it's in between two numbers. I could write it as, we call this a compound inequality. So this is a compound inequality, which means that the answers are in between two numbers. Answers in between two numbers. So to talk more about why all of this, or why this is, I'm going to just go off to the side here. If I have something, the absolute value of something, let's call it blob, and I say that the absolute value of that is greater than 3, I know that that thing has to be more than 3 away from 0. So if I draw a number line here, maybe I should make this number line a little bit bigger. If I draw a number line here, here's 0. I have 1, 2, 3. This is 4, 5, 6. Okay. I know if I start shading the things that the blob could possibly be, the thing that's inside of the absolute value, I know that 4 works because has an absolute value greater than 3. I know that 5 works. That's more than 3 spaces from 0. 6 is more than 3 spaces from 0. So is 3.5. And I can keep going, and this goes all the way to infinity. 3, though, is not included because this is just greater than, not greater than or equal to 3, the distance. So 3 doesn't work, but everything just a little bit greater than 3 works. So I put an open circle on it. We're going to talk about that more in a second. But basically I'm saying the thing inside blob has to be greater than 3. Has to be greater than 3. 3 is not included, but everything greater than 3 is included. Also, if I look to the left, I have -1, -2, -3, -4, -5. Well, -4 and -5 work. -3.5 works. Everything to the left of that works. So everything that's just a little bit less than -3 is possible or works for what blob could be. So I can say that blob can be anything that is less than -3. So if it was -4, that's more than 3 spaces from 0. If it was -5, that's more than 3 spaces from 0. And then these two equations are the ones that you have if you have something is greater than a number. If you have something is less than a number, so let's keep it at 3, then I know that the thing has to be, the thing inside has to be in between -3 and +3. 2, wait, let me just do this. Oopsies. 1 works. That's less than 3 away from 0. 2 works. That's less than 3 away from 0. 2.5 works. So does 0. This works. This works. This works. Everything that's in between -3 and +3. So I can say that the blob has to be in between 3 and -3. I hope that didn't confuse you and helps you a little bit. Also, just a side note for all of this information, if x, so if the absolute value of x is greater than a negative number, so if you isolate your absolute value and you get down to this, you see this here, that the absolute value of x is greater than a negative number. That is always going to be true because absolute value is positive. Every positive number is greater than a negative number. So the answer is all real numbers in that event. Everything for x works. If you have the absolute value of x is less than a negative number, and that's what you've isolated down to, that example is never going to be true. There is nothing you can think of for x where the absolute value would be less than a negative number, because that would mean that the absolute value of x would be a negative number. And you can't have that because distance can't be negative. So this is no solution. And these two are examples you need to look out for to make sure your answer makes sense. All right, so let's do an example. Let's apply what we just talked about. First thing, I'm going to do to solve this inequality, example number 1, the absolute value of 3 minus x minus 2 is greater than 7, is I want to isolate the absolute value. So I'm going to add 2 on both sides, and I will end up with the absolute value of 3 minus x is greater than 9. And then that takes care of step 1. Step 2 is to write 2 inequalities. Now, since I see greater, great or, I know or is going to go in between my 2 inequalities. The first inequality that I'm going to write, and I know I can start writing these two inequalities because this is isolated. I have 3 minus x is greater than 9, just exactly how it is without the absolute value bars. The other option is what's inside 3 minus x is less than. So opposite of greater than, less than, opposite of 9 is negative 9. These are my 2 inequalities that I'm going to solve. First thing I'm going to do is I'm going to subtract 3 on both sides, and I'm going to do that for both inequalities. I'm going to end up with negative x is greater than 6, or negative x is less than negative 12. From here, I'm going to divide by negative 1 to get, I want positive x, not negative x. I'm going to do that in both inequalities, and I'm going to end up with x is, when I divide or multiply an inequality by a negative number from Algebra 1, you should remember that flips the inequality sign. So if it was greater than, it's going to become less than. So x is less than 6 divided by negative 1 is negative 6. Or x is greater than, I flip the sign, negative 12 divided by negative 1 is positive 12. So these are my 2 inequalities that are my answer. When I shade this on a graph, I'm just going to draw the 12 and the negative 6. I put an open circle on 12 to indicate that a 12 is not included, but everything just a little bit greater than 12 is included, and then I shade everything to the right. I'm shading everything that's greater than 12. So 13 is greater than 12, 14 greater than 12, everything to the right is. I put an open circle on 12 instead of a shaded dot because 12 itself is not included, because 12 is not greater than 12. On the opposite side, I put an open circle on negative 6 because negative 6 is not included, but everything less than it is, negative 0.0001 is part of the solution set. So I put an open circle. I need to have a start at negative 6 and then shade everything to the left. And that's my example 1. And example 2, I have the absolute value of 3x minus 6 plus 3 is less than 15. I'm going to subtract 3 on both sides. I'm going to end up with the absolute value of 3x minus 6 is less than 12. I've isolated my absolute value now. I'm going to write the 2 inequalities. This is a less than sign, so I'm thinking less than. I have 2 inequalities with and in between. The first one is just exactly what it is, minus the absolute value bars, so 3x minus 6 is less than 12. The second one is what's inside. 3x minus 6 is instead of less than, greater than, and instead of 12, negative 12. Now I solve these. I add 6 on both sides. That works for both of these. I end up with 3x is less than 18, and 3x is greater than negative 6. I divide both sides by 3, and I get x is less than 6, and x is greater than negative 2. And then I draw this on a number line. Does it make sense? Well, I have negative 2 here and 6 here. They're both not included, so I'm going to put open circles on both of them, negative 2 and 6. I don't see less than or equal to. I just see less than or greater than or equal to. And then I'm shading everything in between. So less than 6, but more than negative 2.